So what I want to look at in this lesson is to kind of give an idea of the time frame in which the Big Bang occurred and then right up until modern time. So we're here listening to this lesson and the time scales involved in that. In comparison to the age of the universe, humans have been around for a very, very, very short period of time, a blink of an eye in comparison to the time scales that the universe has been around and when it started. So what we have here is a calendar. So we've broken it down into the 12 months of the year, and each month represents a specific period or phase within the creation of the universe as part of the Big Bang. So if we take in the Big Bang, so let's say we start in January, so within this time frame we have this singularity. So remember, we have this fine point, and everything, the matter and the energy is all contained within this extremely fine point. So matter and energy. And what starts to happen is it starts to expand. It rapidly expands. Within a second, it has expanded into a huge area. What has. So what we have here is we have expanding space and time. And what happens is, like, within the first couple of seconds, this is extremely hot. So hot, in fact, it's actually unimaginable. There's no temperatures like it in the universe now at the moment, the way the conditions were during this period of time. So it was extremely, extremely hot. And it was so hot, in fact, that atoms couldn't even form. So atoms, which are the fundamental building blocks of everything that's around us, they couldn't form. So the protons and neutrons and electrons, they couldn't actually come together and form up all of the atoms that we have, let's say, on the periodic table. So this is a periodic table, and each block here represents a particular atom, and the difference between these are the number of protons, neutrons, and electrons that are present. So it's just protons, neutrons, and electrons arranged in different ways, and they make up all of the different atoms or building blocks that we have. And then what they do is they come together and they form all of the different compounds and molecules and structures or forms that we see all around us and that are observable in the universe as well. So things were extremely hot, and as the universe, as this space started to expand, what started to happen is things started to cool down. So they started to cool. So it went from hot and it starts to cool down. So January, if we were like, so in January we have the Big Bang, we have the first stars, first galaxies formed. So what started to happen then is, let's say you have this big soup of energy and you have particles and everything, like it's so hot, it's just a big, like, ball of energy. It starts to cool down and you start to get particles, you start to get atoms starting to form. So imagine this is just very simple. So imagine each of these dots represents like simple atoms such as hydrogen and helium. So these are really, really simple atoms on the periodic table. So if we have a look here, so hydrogen is the first atom and helium is the second atom. So hydrogen is just a proton and an electron, and helium is two protons, two neutrons, and two electrons. So really, really simple and basic atoms that were formed. So we wouldn't have even had complex atoms at this stage. And what started to happen is this hydrogen is started to gather up in these big clouds. So you have billions upon billions, octillions, even more, of hydrogen atoms, for example, and helium atoms forming these big massive clouds. And what starts to happen then, gravity starts to take hold. So gravity, if we have the Earth here, for example, so this is a big massive mass of matter. And then you have, for example, you. So the force of gravity really is the attraction between material objects. So what happens is they attract each other. And because the mass of the universe is huge, the mass of the Earth is huge in comparison to us, what happens is we can feel that gravity. It keeps us grounded, it keeps us attached onto the Earth, and it keeps everything else attached onto the Earth as well. Now, this same force, if we only had one atom of helium here and one atom of helium here, they wouldn't attract, they wouldn't have, there would be some attraction in relation to gravity, but they'd be very, very low. Now, what you would have is you would have repulsive forces. So they would actually repel each other. So these are what are known as electrostatic forces. So if you think about, so electrons are negatively charged, so the outside of a helium atom is negatively charged. So if you have a negative coming into contact with a negative, they're going to push each other away. But what starts to happen when you get millions and millions and millions of these hydrogen atoms all close together in a cloud, for example, the force of gravity starts to increase. So a way to kind of think about it is the more mass there is, the more gravity, the more the force of gravity is going to start to take effect. So what starts to happen is these big bodies of hydrogen, they start to attract other hydrogen atoms, and what starts to happen is you get these big massive clouds of hydrogen being formed. And what this does is hydrogen then, if you like, imagine within the middle here, you have a really dense ball of hydrogen gas, and you still have the force of gravity is still pulling more and more hydrogen atoms or particles into this mass, and the force starts to get greater and greater and greater. And then what starts to actually happen is the force of gravity is so strong it starts to take hydrogen atoms, hydrogen and hydrogen, and it starts to compress them together. It starts to push their nucleuses together, and then you get what's known as nuclear fusion. So fusion starts to happen, and what this does is this ball of gas, if you like, it starts to get extremely hot. It starts to get really, really hot. So it's almost like you have like these nuclear explosions that are happening. So you have the force of gravity, all this matter is pulling everything into it, but then with this explosion, it's starting to push everything out as well. So once it starts to push everything out. But what this starts to do is, so this is like, you can think this is like the birth of a star. And it's like a furnace, and it just burns and burns and burns, and it pushes hydrogen atoms together. And what it actually starts to make is helium. It starts to make helium. And then after a while, what it starts to do is it starts to make other atoms, other more complicated elements. So if we look on the periodic table, so we have all of these other elements. What starts to happen is stars eventually they start to make more complicated atoms. So you have these first stars that are formed, and what starts to happen is around these stars you get big gas clouds of matter. So it spews out heat and light and radiation, and it also spews out other atoms that it has formed inside. And these atoms then, what they do is they start to gather in clouds, and they actually start to form, this gravity starts to pull them together, and they start to make like planets and moons and other celestial objects that we'll talk about in a little bit more detail. So if you like, all of this kind of starts to happen on the timescale of the universe. So let's say January, February, we get this kind of process happening. So you've trillions upon trillions of stars and galaxies being formed all over the expanding universe. And these stars really then are the birthplace where solar systems and galaxies start to form around these stars. And what happened then, so let's say this process has gone on from January to February, so we have a cooling down process, stars are being formed, hydrogen is being compressed to make stars, and these stars then are making more complex elements and more heavier elements as well. And then those elements are being passed out into the universe, and then gravity is kind of pulling them together and starting to make the planets and everything else around us. So if we like then, so January, then February, so this process happens in between January and February. Then in March, what starts to happen is the Milky Way is formed. So the Milky Way is our galaxy, if you like, and we're kind of within this, so like we're within this cloud. So again, the Milky Way is formed, and all of the planets and solar systems and all of that, they are gradually starting to come into form. So this process goes on then in April, May, June, July. So just this process of galaxies and stars being formed. So over this long period of time. And then in August, our solar system is formed. So what's happened is within this Milky Way system, within a tiny little fraction within this Milky Way system, we have the formation of the planets and the moons and the stars and everything, for example, that make up our universe that we see here. So we get this star, which is the sun, and then you have all these planets that are being formed by gravity. Gravity causes these things to form. So that's in August time. And then what we think then is around September time, we have the first life form. So our solar system's formed, so the planet has formed, and we get these life forms that are created. And scientists believe at one point they thought that it was simple, like kind of like jellyfish or comb fish, kind of animals like this. They thought that they might have been the first animals that were alive, if you like, these simple organisms that were alive, let's say, within the oceans in around this time. But what they've actually found out is that the first animals that were on the earth were sea sponges, and they look kind of something like this. So these are what are known as sea sponges. So sea sponges, and they reckon that these are the first animals that were formed, or the first animals to develop, if you like. So they're very, very simple organisms, and they are actually animals, they're not plants. And this is a study that was carried out by MIT, which is a university that's in the US. And they reckon that, so roughly about 640 million years ago, so 640 million years ago, these sea sponges were around. And the amazing thing is that these same sea sponges are around today. So they've actually they've outlasted, for example, the dinosaurs and other animals that have gone extinct. So, and then what starts to happen is we have the whole process of evolution. So evolution, where we have all of these different animals then start to evolve on the planet. So let's say around September time, that's when the first life forms, just very simple life forms like sea sponges. So October, November, so these kind of exist, and they do their thing for September, October, November. And then if we take in December, then what starts to happen is we start to get more animals start to form. So December 10th, so within the month of December then, we have more animals start to form. So then if we take, let's say, roughly 15 days later, then we have the first mammals, and we are mammals, and we've come from mammals. So that's when our, let's say, evolutionary tree started. So then the 29th of December, this is when, so between the 25th of December and 29th of December, dinosaurs were around as well, and they actually went extinct. So they reckon there was a meteor strike that hit the earth, and it blocked out the sun, and this killed off large animals such as dinosaurs, because their bodies were so big. They weren't able to get the necessary food that they needed in order to survive, and smaller animals such as so like smaller animals and bacteria and mammals, for example, like these, they would have survived. So then around December 31st then, so at 11:30 p.m., the first humans arrive on the scene. So then if we take on the same day, December 31st, so let's say at 12 o'clock, the first civilizations start to form. So we have, the Industrial Revolution and all the different periods that we went through, the Stone Age, Bronze Age, etc. And then if we take, let's say, December at roughly 1 minute to 12, humans land on the moon. And then our existence goes on from there. But just to kind of, the whole idea of this is to look at In comparison, so if we take, let's say, so all of life and the evolution of life on our planet all happened within a couple of hours, let's say, on the same day, in comparison to the overall time frame of the Earth, or the overall time frame of the universe. And this happened over millions and millions of years. So we can see here 640 million years. That's how long ago the first animals, they reckon, were on the planet. And then in comparison to that, think about months and months and months of time um, have to elapse in order for the universe to actually form and all of this to start. So this it's just to kind of put it into context, like the time. It seems like a long time that we're here on the planet if you look at all of human history, but if you compare that to the length of time that the universe has been around, it's only like it's less than a fraction of a second. So it's an extremely, the universe is extremely old, and it's been around for a long time. And if we're to put like a rough figure on the age of the universe, we're talking about 13.79 billion years. That's a huge amount of time that the universe has been around. And if we take modern humans, so let's say in the form that we are in now, we're talking about 200,000 years. So that's, let's say, evolved Homo sapiens. That's the length of time we've been here on the planet. So for example, if you go back to our ancestors. So like when you put these numbers into context, it's huge lengths of time. Long periods of time. So hopefully that makes sense. And again, it's just to kind of just re-emphasize a little bit more about the Big Bang. And this is science's explanation for how everything came about and where everything started. We started at the singularity. We had a Big Bang. It expanded, cooled down. We had stars, galaxies formed. Then we had planets, and then on the planets, then we had animals started to form on the planets. Okay, so thank you for listening.